Welcome, ladies and gentlemen, to your video lesson for 3.4 graphing functions. All right, so in the beginning of your notes, you're going to notice that there's a warm-up, and it's basically a review of last class on how we determine if something is a function or not. Okay, so it says determine if the relation is a function. Remember, relation is just a set of ordered pairs, right? And a function, by definition, for every input, for every x value, we can only have one unique y value paired with it, right? So when I look at a set of coordinate points, if I want to find a function, right, then I look at all the x values. And in this one, there are no repeating x values. This is going to be a function. This one works out. If I look at this one, I have repeating x values here and here, and those repeating x values have different y's, which means if I were to graph those, just imagine, right? I would go say like this is 5 and then 2, and then 5, 4 would be here, and that would fail the vertical line test, right? And the same thing happens with 11.6 and 11.8. So this would be not a function because we have, if we graphed it, it would fail a vertical line test. But again, moreover, what we're looking for is those repeating x values, right, that have different y's. Okay. Next one. Vertical line test on this one, I can make it fail. Remember, you tried to make it fail. So because this vertical line hits the graph twice, this is not a function, so this would be no. And this one passes the vertical line test, so that means that this is a function. So this one checks out. All right, so moving on with the lesson today. The big deal here, oh, sorry, I forgot about, we had one more problem. So number 5. Oops, sorry about that. All right, excuse me. So Mary already sold $55 worth of tickets to the benefit concert. She has X tickets left to sell at $7 per ticket. It says write a function using function notation to describe the situation. So remember, function notation, this is an example. This is not the same. If I wrote y is equal to 2x plus 4, right? That is not function notation, but function notation just replaces the y with this f of x, right? It's a function evaluated at some value x. That's really what it means, right? And then we still have the 2x plus 4. So that's how we do it. So now I want to write this one. So if we write it as a normal equation, it would be y is equal to, and then we already have sold $55. So 55 bucks plus, and then $7 per ticket. That's going to be the 7 times x, which x is a ticket, right? So we'll say x equals number of tickets. I'll abbreviate that TIX. And then if I want to write that in function notation, all I got to do is replace the y with an f of x. So it'd be f of x, that's a fancy f, by the way, is equal to 55 plus that 7x. That's what we're looking for there. Okay. All right. What are the independent and dependent variables of that problem? So the independent variable, remember, is what's going into the function. It's our x value. So what does x represent? We said tickets, right? So tickets is the independent variable there. And then what is the dependent variable? It doesn't really define what that is. So you have to kind of make sense of it. She's just selling tickets, and our equation is about money, right? So it's like total sales or total money brought in. And so we're going to say that it's the total sales. It's whatever we say the f of x value is there. Okay. Then if she sells 3 tickets, if she has 3 tickets left to sell, rather, what is a reasonable domain and range? Remember, reasonable domain and range means what makes sense for the scenario. Well, if I have 3 tickets left to sell, and that is my independent variable, it's what's going into the function, that's my domain, right? So if I have 3 tickets left to sell, that means I can't have negative values. That doesn't make any sense. I can't sell 1.2 tickets. And so what numbers are we talking about? Well, I could potentially sell no tickets, right? I could sell 1, I could sell 2, I could sell 3. That is my domain. My domain is 0, 1, 2, and 3. Now my range is the corresponding output for every input here. So if I sell 0 tickets, it's like 0 is going in for x, right? So 7 times 0 is 0, and I get 55. Okay. And then if I sell 1 ticket, well, it's 7 times 1 plus 55, which is 62. And then if I sell 2 tickets, so that's 7 times 2 plus 55, which is 69. And then for the last one, I sell 3 tickets, right? So it's 21 plus 55. And so that's my range, okay? So every one of these values are essentially, if I were to graph this, right, these would be matching corresponding points or coordinate points, I meant to say. Okay, so let's move on with today's lesson. Our big deal here is just graphing, okay? Taking a function, coming up with coordinate points from the function, and then putting them into the graph, all right? I'll be going a little bit faster than what I normally would in a class, but again, it's a video. You just pause it, go back in the video, whatever you need to do. All right, so how do we graph functions? Well, if this is the function that I'm given, okay, it's x plus 3y equals 15, and I'm given a domain, right? And my domain that I have to then use is 0, 3, 6, and 9. Remember, these are my x values that I will put into this function, right? And then I will figure out what my y values are. Now, when I'm looking at this isn't the most convenient way to figure out what my y values are. So what I really want to do is have an equation that looks like y equals some stuff, because then what I'm going to do is I'll substitute those x values into that equation. I'll do a bunch of simplifying, and I'll get what y is equal to, right? I'll get it right away. So my first step is going to be to solve for y first, right? So when I do that, I have x plus 3y is equal to 15. I'm going to add x to the other side. I'm sorry, subtract it to the other side. So then I'll have negative 15 plus x, or 15 minus x, either way. I think I wrote 15 minus 3x here. Then I'm going to divide by 3, and everything gets divided by 3. And so what happens is I end up with this y is equal to the opposite of x divided by 3 plus 5. Okay, so that's the equation that I'm going to roll with as I do this. So now all I have to do is substitute x values in. I substitute in my x values, right? Take the opposite of it, divide by 3, add 5. Done. And now I have to do that for every one of my domain values, okay? So this is the work for substituting in 0. I substitute in 0. 0, the opposite of that is 0. Divide by 3 is 0, and I add 5, and I get 5. So my first corner point is 0, 5. Then I substitute in 3. Negative 3 divided by 3 is negative 1. Then if I add 5, I get 4. So my next coordinate point is 3, 4. If I substitute in 6, then I have the opposite of 6, which is negative 6, divided by 3, which is negative 2. And then I add 5, and I get positive 3. So my next point is 6, 3. And then for 9, I do the same thing. Negative 9 goes in for x. I divide by 3. I get negative 3. I add 5, and I get 2. So now if I graph those points, I end up with a straight line. Notice before we've talked a lot about, like, if you get a squared value, you're going to get a curve, right? It opens up or it opens down. This does not have the squared function, so we should get a straight line. But since I gave you a specific domain, right? I told you what specific points to graph. It means we do not connect these points, even though you're going to be really tempted to draw a line there. If I do give you a domain, we do not connect the points. And that's pretty much all there is to it here. We take the domain that we're given, we substitute in values into the function, right? We have our x values, we put them into the function, we get our y values, and then we just graph the coordinate points. That's really all there is to it. So here's an example of the same thing. I have my function y is equal to negative 4x plus 2. Since this already has y by itself, I don't have to solve for y. This is a good one, okay? So if you're not told what the domain values are, that means you can pick whatever domain values you want, right? And so typically we want to pick values that look kind of like this. We want to pick values that are on both sides of the graph, and we want them to be kind of evenly spaced so we can get kind of a general idea of what the shape of the graph looks like. So we usually pick like negative 3, negative 2, negative 1, 0, 1, and 2, and 3. So for all of these, that's what I have, all right? Come on, move over. All right, so here I am substituting in negative 3 in for x, right? And for this. So I have negative 4 times negative 3, which is positive 12, right? So I have positive 12 plus 2, which is then 14. So I have negative 3, 14. This is actually off the graph. Negative 3, 14. I know this goes out to 10. 14 would be, somewhere in this area. Then I go ahead and do negative 2. Negative 4 times negative 2 is positive 8. Then I add 2, and I get 10. So I have negative 2, 10, and negative 2, 10 is on the graph, so negative 2, 10 is right. Yeah. Do the same thing with negative 1. Negative 4 times negative 1 is positive 4. Positive 4 plus 2 is 6. Point negative 1, 6. So negative 1, 6, 1, 2, 3, 4, 5, 6 is right there. It's starting to come along kind of nicely. 0 is the easiest one, right? Negative 4 times 0 is 0, and I add 2, I get y is equals 2. So I have 0. And then chugging right along here, plugging in 1. Negative 4 times 1 is negative 4, plus 2 is negative 2. So I have the point 1, negative 2. So 1, negative 2 is right there. Positive 2 substituted in. Negative 8 times 2, negative 4 times 2 is negative 8. I got to simplify that first, right? Then I add 2 to get negative 6, so y is equal to negative 6. So I substituted in 2, I got negative 6, so I have the point 2, negative 6. So 2, 3, 4, 5, 6, right there. And again, last one here, substituted in, I end up with negative 10. So I get the point 3, negative 10, which I know is right here. And again, kind of a self-check, right? It's not a squared value, so I know I should get a straight line, and all of my points are graphed in a straight line. So if it wasn't, right, so let's say this point ended up being like way over here or whatever, okay? One of two things happened, right? I either did a calculation incorrectly or I graphed it wrong, and I just go back and figure out which one of those things it did. But that's how we kind of do a self-check there. All right, example 2. Now we have the opposite of x squared. So the key to this one is remembering that when I substitute in, this negative doesn't go away, right? So if x is going to be equal to negative 4 for this, then I would have f of x is equal to opposite of, because this negative can't go away, and then I substitute in still a negative 4 and I square that, okay? And so I'm going to reveal the values here. Substitute in negative 3. Negative 3 squared is positive 9. And negative is still on the outside of parentheses, right? So it still gets applied. So I have 3, negative 9, which I will then graph. Negative 3, positive 9. 1, 2, 3, 1, 2, 3, 9 is way up here. Then for the next one, I got negative 2 that I'll substitute in. Negative 2 squared is positive 4. Then I have the opposite of that. You get negative 4. I substitute in negative 2. I got negative 4. So that is negative 9. I made a mistake here. I made a mistake right there. My bad. So hold on a second. Can't be awesome all the time. I gotta move this point. I gotta see the whole graph. Right there. My bad about that. Okay, and then moving right along here, negative 2, negative 4. 1, 2, 1, 2, 3, 4 would be right here. All right, substituting in negative 1. Negative 1 squared is positive 1. Take the opposite of that. We get negative 1, so we get negative 1, negative 1. Boom, right there. Substitute in 0. We get 0. I think that's pretty clear. If I do 1, right, that's just like positive 1 squared is 1. Take the opposite of that. I still get negative 1. And so again, when we have a squared function, right, we expect to get some type of curve, right? And that's what's happening. So I get negative 4 when I substitute in 2. Again, you can check the work there. 2, negative 4 is there. And then 3, I get negative 9. Again, you can check the work there. And so my graph looks like that. Okay? So again, all we're doing there, big key to this is remembering not to get rid of that negative value that's in the function. Okay? I'm going to clean this up a little bit. All right, next one. This now says f of x, but remember f of x means y, so we're kind of just changing that. So we have a function, and again, all we're doing is substituting in the values of x. So substitute in negative 3. Negative 3 times 2 is negative 6, and I subtract 3 to get negative 9. So I'm going to plot negative 3. Again, negative 9. I don't want to graph that wrong again. Negative 3, negative 9 is right here. Substitute in negative 2. Same type of work, right? I get negative 7, negative 2, negative 7 is right there. Negative 1, I substitute in. Negative 2 times, negative 1 times 2 is negative 2. Subtract 3 more and I get negative 5. So that's going to be right here. And again, looking at this one, it wasn't squared, so I know I'm going to get a straight line. It's turning out that way, so that looks good. 0 is the easiest. 2 times 0 is 0. Subtract 3 from that, you get negative 3. So I have 0, negative 3. Still in that straight line. If I substitute in 1, 2 times 1 is 2, minus 3 is negative 1. So I have 1, negative 1. Still in that straight line. Substitute in 2, I get positive 1. So 2, I get positive 1. It's still straight line. And then for 3, I get 3. So 3, 3. Again, you can pause the video, kind of check the work there. This is the stuff that we expect to see when you guys take a quiz or test. Okay. All right. Fourth example. This is just x squared. Again, go through it one at a time here. Because, now pay attention, this one doesn't have a negative, right? So let's say x was, again, equal to negative 4. If I substitute that in, that's negative 4 in parentheses squared. Again, that means negative 4 times negative 4. So we get a positive out of that for 16. So if you look at this, I'm substituting in negative 3. I get 9 because negative 3 times negative 3 is 9. So I have negative 3 positive 9. Next one, I substitute in 2. Negative 2 squared is 4. So I have negative 2, 4, which is right there. Negative 1 squared is 1, so I get negative 1, 1. 0 squared is obviously 0. And then when I do my positives, it's really, really clear, right? 1 squared is 1, so I get 1, 1. 2 squared is 4, so I get 2, 4. And 3 squared is 9, so I get 3, 9. And again, because we have a squared function, right, we would expect to see a curve, and that's exactly what we get. I graphed that in the right spot. Yep. Okay. Just kind of looked off. All right, so that's what the graph should look like. So again, all we're really doing is substituting values into the function, getting our y values, and then plotting those values. All right, so number 5. Now we are going to look at a graph and then answer questions based on it, okay? So I have the graph y equals x squared. This is the exact same one that we just graphed, right? And so we can see how the graph goes down and then back up. It's called a parabola, right? So we have the same values. We even have the same values graphed, right? Negative 1, 1, stuff like that. It says, what is the value of y when x is 2? So here's how you do that. You go to the x-axis. You find where x is 2. Now, this counts by 2, so x is 2 is right there. And then you go up to the graph where it hits, or down, wherever the line might be. You go to the line, right, along x equals 2, and you find where the graph is. Then you go over to the other axis to find your answer. So based on the graph, I would say y is equal to 2. Then I can ask the other question. It says, well, what is the value of x when y is 9? Now notice before it was x, now I'm asking when y is 9. So I do the opposite now. Now I go to the y-axis, right? And I look for where we have 9. So 9 is right here. Now the line is actually on both sides. So I get 2 answers out of this. And it makes sense because on the table, right, we had 9 appear twice. And so the table actually tells us what our answers are going to be. It's going to be negative 3 and 3. But let's look how we can find that on the graph. From the y-axis, I go over to the graph to the right. It's here, and where does that go down to? It goes down to 3. So I'm going to get x is equal to 3. I'm also going to get x equals another value. So I go over to where it hits 9, and I go back down, right? And it hits at negative 3. So both those values. That's how we use the graph. Same thing happens when we do a linear graph, except for we won't have those two sides ever, right? So what is the value of x when, what is the value of y when x is 3? Well, when x is 3, x-axis, x is 3 is right here. If I go up to what y is, right, it's there, and my y value, y is equal to 4. We'll change color just for fun here. And then what is the value of x when y is equal to negative 8? Well, if I go to negative 8, when y equals negative 8, rather, sorry about that. When y equals negative 8, go to the y-axis, which is right here, right? When y is negative 8, it's there. So then I go over to x, and now that x value looks like negative 1. And that's how you use the graph to find values of x or y. All right. Last question here. I'm going to go ahead and use the shade to kind of cover up some stuff. All right. So it says a cruise ship is currently 5 kilometers away from the port, and it is traveling away from the port at 15 kilometers per hour. The function y equals 15x plus 5 relates the number of kilometers y, so y represents the number of kilometers. The ship will be from its port x hours from now, so x represents hours. Let's graph the function below. So the first thing I want to do is get values into my table. Once I get values, then I need to look at, and I've already done this, I need to look at and then maybe adjust my scale, right? Because maybe it doesn't make sense to count by 1, 2, 3, 4 if my values go up to 1,000 or whatever the case might be. So you got to get your values first before you can make a scale. Some of you get into the habit of just like, boom, right out your scale right away. And then you get your values, you're like, oh crap, I can't graph 100 because I counted by ones. Always get your values first. So going back to this equation, let's kind of make sense of it a little bit. 15 kilometers per hour, we get that 15x because now we're multiplying 15 times each hour, right? And so in 2 hours, it'll travel 30 kilometers because 2 times 15 is 30. And we have that plus 5 because we're starting at the time 0 where it's already 5 kilometers away. So no matter how many hours we add to this and get a certain amount of kilometers per hour away, we always have to add 5 because we didn't start counting until it was already 5 kilometers away. So that's how we get this equation here. And this is no different, right? So I'm, again, given values in the table that I have to use. And so at time 0, this is kind of easy because I substitute in 0 for x. So 15 times 0 is 0, and I add 5. I get y is equal to 5. So I graph the point 0. I'll maybe do this in red. I'll graph the point 0, 5. And I've already made my scale to count by tens because I know that this is going to be really high, right? So 0, 5 is right there. Then I put in 1. 15 times 1 is 15, plus 5 is 20. So I graph 1, 20. There. I substitute in 2 hours rather. 2 times 15 is 30, plus 5 is 35. So I got 235, which is right here. And then I do 3. 3 times 15 is 45, plus 5 is 50. So I go to 350, and that is right there. Now, I know I gave you this domain to choose from, but this is very, very much certainly a continuous situation. It's not like the cruise ship is going to just magically appear at these various locations in certain instances of time. So it covered all this distance, so this should definitely be a line that is connected, and the arrow should be there to indicate that it's going to continue on in this pattern. Now we can answer some questions about it. It says, use the graph to determine how far the cruise ship will be from port 2.5 hours from now. This is the same exact thing as saying, like, what is y when x equals 2.5? Well, when x is 2.5, then I have to go to the graph where x is 2.5. That's right here. Then I have to go up to the graph where it hits it, and then go to the left to analyze what I think that is. Now, this is always an estimate, right? But this is what's required. Like, I need to see this in order to know you use the graph. I don't want you to use the equation. We already used the equation 4 times, right? By substituting values. I want you, the skill here is knowing how to use the graph. So the graph tells me that it's about 40, right? So I would say that the cruise ship is 40 kilometers away, according to the graph. All right, so hopefully that was helpful to you. That was just a quick lesson on how to graph. Remember, our key skills here are being able to take our domain, our input, our x values, put them into the function, do the calculation, and get our y values out, get our range out, right? Our output, our dependent variable, and then put those together, the input and the output in the coordinate point, graph those points, and then we have a graph, okay? Then once we have the graph, we can always analyze it by looking at different points on the graph like we did here. You know, if it was 2.5 hours away, we went to the x value on the graph and find out what the y value was, and then we were able to answer questions, right? I hope you guys have a really great day. Peace out.